explainable AI. Can you explain what artificial intelligence really means and what is explainable AI, why AI is a black box? Hi, and welcome to my channel. My name is Roy Yosevich, and if this is your first time in the channel, please consider subscribing and hit the bell button. And in this channel, I host and speak with the most prestigious and important scholars from all around the world to discuss topics such as philosophy, science, intelligence, artificial intelligence, religion, and even more. And my guest today is Dennis Rothman, and it's a pleasure to have him on the show. Let me just say who Dennis Rothman is. He graduated from the Sorbonne University and Paris Diderot University. He is a pioneer of the very first word to matrix embedding solution, and is the author of 3 books up until now, including Explainable AI, Artificial Intelligence by Example, which is a great book, by the way, and most recently, Transformers for Natural Language Processing. So Dennis, thank you so much for being on the show. How are you?
Well, thank you for inviting me. You know, I was... if you didn't invite me, I wouldn't be on the show. So thank you very much for being here. So you wanted to know what artificial intelligence is?
Yes. But just I want to know so many things, and you are in the world of artificial intelligence for approximately for the last 35 years, including the big AI winter, where many people thought that artificial intelligence was not the optimal or the best route to take in order to solve those problems. So before we dig in to what's happening now, how was it back then, in those days, to be in the field of AI during this long, cold winter?
Well, first of all, I started out in 1978, so it's more than 35 years. And I found that I was bothered by the way people were approaching languages. And I said, there are just too many rules. I want to do some statistics. So I did some expert system rules and statistics. And in the beginning, I was just working on pieces of paper. So I just had pieces of paper and I was putting my ideas, and then I was testing it on students. I was using students as machines. So I was teaching them like I would teach a machine. And then I registered a patent in 1982. I was thinking the best way for me to do statistics is to convert all these words, to break them down into little pieces and put numbers. And that way I can use the numbers, and then I can go back to these little pieces of words. So I began with phonemes. I began with sounds. Then a few years later, I said, well, why don't I make a conversation with this system? Now that I have my numbers and I have my patterns, I can build an expert system where the system can communicate with someone else, but I can add some statistics in it to make it both rule-based and statistics. And fortunately, I sold my first algorithm to what is now Airbus, which was aerospatial in the defense department, to optimize what I can't talk about. Okay, so, and the person says, you know, we don't know what you're talking about. We're just going to give you 6 months. And if in 6 months it doesn't work, we're going to take your house, because you're going to write that you agree to every condition of the contract. So every day late after 6 months, you will pay. So I said, yeah, okay, let's do it. So I did it.
I don't know if this is a good policy. Any young startups guys who are listening now, I don't know if this is a good policy, you know, what Dennis did back then.
I was in those days an insane surfer. I could go on big waves and just fall in the water. I didn't care. So I'm not saying following my example. Maybe you have to be crazy. So anyway, especially with this kind of people that would come to my garbage cans and look at security all the time and listening to my phone conversations. So, but I didn't mind. All I wanted to do is get the reference. After 6 months, I delivered, and they deployed it on 200 sites. And they said, we're not going to give you money for the other 200 sites. because you're lucky we even hired you, so it works. But we're going to give you a reference letter. And on this bill, we're going to give you an order, and it's going to be written artificial intelligence system. And I still have it on my computer because with that, I could go anywhere. And I said, you know who said that? Aerospatial. You know what Aerospatial knows? Airbus. Second customer, LVMH. LVMH, the brands, the luxury brands.
But just a second, before we move on to the next customer, I think that it is important to set out, the terms. Expert systems, which are part of what we said, are part of the big world of AI, at least according to Norvig and Russell, but those are not neural network, deep neural networks. Those are basically systems that has rules written by experts, or those are the expert system, and those rules enable us to deduce or to give information or to act intelligently or allegedly intelligent based on what expert in the field know. Is it a good way to put it, what expert system is?
Well, you're almost in the beginning of the conversation I had when I was selling my algorithm, except that I didn't build an expert system because I was working on a little processor called a 286. So if you had wanted to enter rules, that was what they were trying to do for years. They were trying to enter rules. And I said, it can't work like that. So I invented one of my first optimizing algorithms. Now, to explain it in simple words, I would say it was very few lines, and each line had a different function depending on the context. So every time a context would come in, the program would react differently. So it wasn't an expert system. It would go around and it'd come back, and every variable would change. And it would be like sparse models. I don't know if you know sparse models.
Yes, but it's like a very simple version of recurrent neural networks that you don't only need the input, but also the context, which was the input of the last phase. Can I put it that way?
No.
Okay. No. Okay. Very good. So please do explain.
I'll give you an example. You take it like you take a car thief. You know car thieves? They have very good car thieves now, and they want to rob a Ferrari. So they come along and they have this machine, and it will run all sorts of combinations until it finds the combination that will open the door and start the car. Intellectually, I didn't have to solve a problem like that. I had to solve another one, but I designed it in a way that there was a result that was expected, and there was an input, and the variables had to organize themselves in a way to answer that output. So it's just, I wouldn't call it anything. I would just call it would be, in fact, closer to what transformers are now, because transformers have nothing in them. It's just a plain equation with three variables and a lot of parameters. So let's call it just an optimizing algorithm that's between expert systems and neural networks.
Okay. Okay, so before we move on.
And it took 6 months for the people to understand that algorithm because I had to print it out and give it to them.
Yes, but I teach the Kalman filter and the particle filter, and what I teach my students is that don't judge an algorithm by its length, because the Kalman filter, it's approximately 6 lines or 8 lines of code, but it is a very powerful tool. It's a very powerful technique, and it's a very powerful algorithm. So the measure like an algorithm or the efficiency of an algorithm by lines of code is a very bad policy. Now, I want, because with your permission, I would like to start with your first book, which is Artificial Intelligence by Example. Now, you are, among other things, now a teacher and an author who writes a book. So it basically makes you a teacher. And I also teach data science and machine learning in the university. So I would love, what's your definition of a good and a bad data science AI book? If I, as a student, okay, I want to purchase, I want to learn, I want to invest my time in learning the book. What would be a good book? Don't give me an example, but what good data science book or AI book consists of?
Well, what I try to do, and unsuccessfully many times, because I would like to take more time and people are not ready for this, is a book that goes from everyday to algorithms. I was one of the first teachers of computer science at the Sorbonne in the 80s. The field hardly exists. And I would tell a person, I remember the course, I would say, and the people say, where's the code? I said, hold on a minute, we don't need code. Oh, you don't need code? No, you don't need code to learn algorithms. Oh, where's the math? I don't need math either. Then what do I need? Think. You're on a street and you have to cross the street to go to the baker's. You have to buy a baguette, French piece of bread. Tell me all the steps you think are necessary to go there. Nobody ever succeeded, but they all tried. Some people forgot to look left and right on the street and they got ran over. Some people got to the baker's shop, but they didn't find that the baker was closed that day. Some people entered, they didn't say hello. Some people forgot money. Some people just took the bread, didn't say thank you. Some people even forgot to ask for the bread and went out of the baker. Out of these students, I had hundreds of them, and not one of them put it straight. So I would say the first thing to do is, before you read a book, sit down and develop a mathematical eye. Begin to think. Look at your cat. Your cat is probably better than you in algorithms. Open the door to a cat. He won't go out. Half of the time, the cat won't even walk out of the door. It'll sit there and it'll look outside, it will smell, then it'll look back inside, decide if it's warmer inside, cooler outside. It's using an algorithm. It's a very powerful algorithm that goes back millions of years. And then go observe ants. I spend days looking at ants, the way they work. So if you don't understand the way the world works, then don't spend your time on algorithms. And what I did with all the people I taught in my corporation, because I had to teach all these, not my corporation, my small company, I'm sorry. I worked for corporations, but I had a very small company, a very successful small company. I would take the person and go to a factory. And it says, yeah, but we're going to be doing no, you don't need your laptop. I don't need my laptop? No, you're going to be a worker. What? What, you mean a worker? Yeah, they agree. We're going to go to a textile company. You're going to spend your day carrying rolls of material with me. Then we're going to cut them. And you're going to try to sew them. You're going to do it badly. And then we're going to go wash the jeans. He says, I don't know how to do that. If you don't know how to do that, how are you going to write an algorithm or even have data? So to sum it up, I believe in the physical world. And from there, you observe and you begin to draw relationships yourself. And then you weigh decisions yourself. You say, oh, I want to go on vacation, but I don't have enough money. I want to go on vacation, but I have to take an airplane. I'm afraid. And then you put all these parameters together. Now you're ready for an algorithm. So
okay,
book,
but
what I try to do in the book is to always bring a use case in it and work on it. And give some math, subject expert matter, some math, and then the program.
Because what you're saying, which is fascinating, is so profoundly different from the way universities all around the world teach math and computer science. We start with the math, with the heavy math. We start with calculus and linear algebra and all this Java and classes and object-oriented. And we rarely take a step back and look at the big picture, what you said. So just like we don't need code, we don't need anything, we don't need math, just hold it and think for yourself. This is a very different approach than the approach that I think almost all universities take, no?
Yeah, but you're going to begin to know me. I don't care what other people do.
Okay.
But I'm going to tell you something very important. When you mention the word math, I have children and now I have grandchildren, and I help them a lot with math. The first thing I explain, I said, when you learn math, go look at Notre Dame in Paris. You know, there we have this big cathedral that burned a bit a few years ago.
Yeah.
That cathedral was not built with math. That cathedral was built with geometry. And they were using Roman numerals in the 12th century in France. They had no math. The Arabs had math. We didn't have math in France. So they had a stick with a rope, and they use it as a compass. And then they had a ruler, which was just a piece of wood. And they built that cathedral with a ruler, and then just a square ruler, and then a piece of string with a lead. And what did they use? They use what I just said, reasoning. Okay, let's do it this way. Then you have to reason with geometry. And that's not me, that's Henri Poincaré. And that's Gaston Bachelard. Because we're forgetting all these people that did some very excellent things. You don't begin with calculus, you begin with geometry. What's that proportion? How does that work together? What's the design of your algorithm? Geometrically, what does it look like? Is it a square? So once the children acquire the geometry, then they can understand. I'll give you an example. My granddaughter had problems with proportions of a cake because the teacher, of course, did like you said, divide this by that and do this by that. And she said, okay, so go get a cake. You just took a cake and I said, you know what? I'm going to cut the cake this way, and that's what you're going to get. You say, what, are you crazy? You're taking all the cake and you're giving me nothing. Yeah, but you said you don't care about proportions. Yeah, I do. So then divide it. Why don't you divide that cake equally? And then she divided it perfectly into 4 parts. I said, now you did a 4th. Now divide it again because we're 8 people. Then she did an 8th. Now we have connected reality to math, and now math makes sense. And if you do that with every single thing in math, math is so easy. Calculus, all that's so easy. It's just because it's been taught disconnected totally from what it's supposed to be. And once you reach a level of abstraction, of course, then you don't need to go back anymore.
By the way, I think that what you are referring to is called in learning theory the Feynman technique, which for every abstract or complex subject that you're learning, try to find your concrete everyday example that you can relate to. Now, again, this might be very difficult with quantum mechanics or like very advanced math because what you say about proportion and cake, and even the Cathedral of Notre Dame could be built with ruler and a stick or a piece of rope, but something when you reach a level of abstraction, of complexity, you cannot do it just using the rope and the ruler. You need something else. But this is a very nice approach that you need, okay, go back to the basics. Now, with your permission,
let me give you an example of what you just said. Okay, everyone is speaking about Albert Einstein with the theory of relativity. Okay, that is the cliche. It's as if this guy just lived all his life and all he wrote is one equation that everyone sees in every book. Okay, no. But going back to what I was saying, you have Albert Einstein sitting around and he's watching sun. And he's watching the sun on objects. He takes it on objects and he's saying, it's so funny. It's so funny. It's hitting an object. Okay, let's say I put a book in front of me. Okay, the sun, light is hitting the object. Okay. And he's saying it's strange because the way I sense it, my intuition, he had no math. There was no math at that point that existed. My intuition is it's funny the way it reacts. There's energy in there, but the energy doesn't seem to depend on the intensity of the sun, but maybe just the frequency. That's what I think. Why don't I call these little packets, I'll call them quantas, because you're speaking about quantum. He's just thinking with a piece of paper. Okay, and Albert Einstein wasn't even good in math. You know that he spent 2 years and he had to go back and do it all over again.
He was heavily relied on Poincaré for doing many of his mathematical calculations.
So in 1921, with his intuition, he just wrote a simple paper. What did he get? Nobel Prize. How does this work? Sun panels today. So what I'm saying is, now I'm cheating a bit in this conversation because I'm a great fan of Cédric Villani, which is a field medalist, French field medalist. And I watched a tremendous amount of his conversation. And in fact, I even received a message from him one day for what we might talk about later. He always finds a way to explain within a metaphor, even chaos, when he says, I remember in one conference, says, take a leaf off a tree and you drop it, it'll never drop in the same place. Okay, he's referring to Boltzmann fields and stuff like that. But I think you always can. And it goes back to what I believe, a very deep belief that you may understand. I think that our brain is not new. It reached a point 20,000, 30,000 years ago, the way it is today. And I'm thinking that our ancestors were extremely complex. It's not what we're thinking. They had to remember if you're in the desert, they had to remember all the places where water was. They had incredible memories, incredible mind maps. So I think that everything can be related to something physical. There's this book called The Zoomable Universe, the Zoomable Universe, and the man explains everything with a zoom. If you go under, you get quantas. If you go over, you get planets. So I think everything can be explained with a concrete, even the most abstract concept.
Which is great because in a few minutes we are going to move on to what we call explainable AI. Now, another thing, there is a nice analogy in this lovely book, Machine Learning for Engineering, and this machine learning in engineering. And in this book, he said basically the following thing. So machine learning, when you say machine learning, different people mean different things. And one of the things, it's like making food. So there are two types of making food. One is to prepare the cake, and other is to build the oven. And many machine learning books specialized or dedicate themselves to build the oven, how the algorithm actually work, and not how to use it, how to utilize the algorithm in order to make the cake. And I think that this is a very nice metaphor. So basically what we would like to do is to train people to use the oven instead of understanding its mechanical parts. But most machine learning and deep learning books, especially like this one, like this Deep Learning by Ian Goodfellow and others, are mainly interested in, I want you to explain how the oven works, the inside mechanics, and not how to operate the oven and make your food. So what's your take on this?
So my first take is that book you just showed, Goodfellow. In fact, it answers the question. There is no single book that will help you. You have to buy several books, and you have to let them interact with your personality. So maybe you need 10 books. There's not one book that's going to, you might be inspired. For example, the best book I've ever seen in my life in the computer field, and it's never far from me, wherever I am, is Michael Nielsen's quantum computing book, or there's 11 editions of that book. So that book is like, I don't know, every time I feel bad about, I just open a page and I feel good. I mean, it's
great book.
But it's the book I related to. Maybe for another person won't like that book. So what I would say, buy several books, even buy your book on magic. Maybe if magic is an algorithm, there are hidden variables. There's the input. There, what we see when we look at you make a magician. Then there's the hidden variables, and then there's this output that surprises us. And then you ask the magician, what's the trick? Which is one of your next questions. So there are you have the input, the hidden variables, and the output. There you have a book on artificial intelligence right behind you. It's called Magic.
Yes,
so
over there. So with your permission, last question before we move on to explainable AI. There are many articles that I recently read towards data science and Medium and Gradient that stop doing tutorials, that many people are getting addicted to doing tutorials, but tutorials are just good for your first phase. And after that, you must let go of the tutorials and do a project like project-based learning or other things. Because when you do a tutorial, you follow the step of you just following the steps of the author. And when you try to deviate even a little bit from what the author guided you to do, you know nothing. So many people advise, and I myself advise my students, get away or don't be addicted to doing tutorials. So my question is twofold. One, would you consider books like your books like artificial intelligence, by example, are like a big version of a tutorial? And would you agree that tutorials could be dangerous if you want to progress by your own?
Well, there's so many thoughts coming to my mind. I'd like to say something, since it's a conversation. I would like to I'd like to go back a few hundred years to Gaspard Monge, which is optimal transport. And Gaspard Monge just had to solve a simple problem, take the coal and bring it to the right factories, and he did it, okay? But if you take optimal transport, that was done 50,000 years ago. What do you think our ancestors did when they had to go get water? They did optimal transport. What do we do in deep learning? We transport weights through the layers and we go back and forth. What do we do in tutorials? We're transporting knowledge in our brain. So if we're sticking to the same road all the time, we will never see the forest. We'll never see the flowers. We'll never see the sky. We're just stuck in a road. So I believe in the incredible concept of optimal transport that you can represent in vectors and you can represent in space. And once you represent that in space, well, you're back to my concrete world. So I'm bringing the student from his real world to a vector space in which you can play with optimal transport like you did 50,000 years ago, because once again, I don't think our brain changed. Okay, and in fact, we still have the same emotions and instincts we had 50,000 years ago. Okay, so now you come back to the book. When I write a book, I keep trying. I'm not saying I succeed, that is for the reader to decide. I keep trying to bring people back to reality. So you take artificial intelligence by example, the first thing I do is show them the graph and show that it can be used. I talk about transportation of someone stuck in traffic. I try to relate it always to something physical, because I don't believe that much in abstraction, because of a concept which is very well known in France with the postmodernists, and is the notion of map and territory. You know, that the map is not the territory. So there are many stories like that about map and territory, but the map is not the territory. So as long as you're in abstraction, you have to bring it back to the territory. So I would say a book, what I try to do, like in chapter 3 of Artificial Intelligence by Example, I give them a chess example. I say, take this position of chess between these two players. How can they analyze it? And they say, well, a human being can analyze it. But I say a machine can analyze it better. And why can't a human analyze it? And I did this with a chess coach, because I took 300 lessons, private lessons, with an international chess master that played at chess with all the great players. He's from Serbia. So, and we looked at this position. It's something we study. And we found out by reading all the articles that neither player at that time in that game knew what to do. It was just too complicated. So they were just sitting there and bluffing and thinking, but they didn't know what to do because there were 30 parameters each and they didn't have the time to go through them. So I just try always to go in my books from a real situation to an abstract situation. And I think that someone that reads these books, like in Explainable AI, I begin with a doctor talking to...
Yes, the Nile fever.
Yeah, the Nile fever. So, and in fact, I did that. I began that chapter with my nephew, who's a doctor. And I said, what's the biggest problem you have? He said, well, someone comes with a fever. He just says, I have a fever. And I have no other symptom. I don't know what to do. I have to wait. I say, well, just take some aspirin until I find out. And then the next day you have to do blood tests. Then you have to go into an investigation. So my leitmotif is, don't forget the real world. The real world is there, and always try to, even if you're reading the book by Goodfellow where you say it's abstract. I read that book and I really liked that book. I would read it an hour a day at one time, and I read a chapter 10 times because every time I would read the chapter, but I would transpose it into my real life. I'd say, how would that work if I did this and that? So it's up to the reader also to bring it back to his life.
But, maybe the question is, you eventually, the definition or the implication of getting back to life is basically writing a code. But this leads me to the next big subject, which is explainable AI. Now, explainable AI, with your permission, let me just do a little exposition or introduction. Basically, AI or artificial intelligence, mainly neural network, deep neural network, are black boxes. When I say black box, I mean that I know what the output is, but I don't know why the output is the way it is. So I know that my convolutional neural network, for example, classified this image as a cat, but if I say, yes, but why this image is a cat, you don't know to tell me. Now, there are ways in order to interpret your results. For example, very simple way is to do linear regression. In linear regression, you have weights. So it's sigma WIXI. So if I have all the weights of the different features, I know, okay, this weight is the biggest, therefore this feature is the most important. So I can understand it in the way of linear regression, and I can understand it in the way of decision trees. So if I have decision trees, so if you are more than 30, go there, and if you are a man, go there. So I have like if-then rules, and I can interpret if-then rules. I can interpret the value of the different weights in linear regressions, but that's it. And if it is a very big neural network or a very big deep neural network, if you want to understand why I got the results I got, so it's very hard and almost impossible. So did I sum it correctly?
Yeah, each perspective is correct because it's your perspective.
No, but this is postmodernism. No, there is one truth. But basically, would you say that decision trees are much more explainable and linear regression are much more explainable than deep neural network? Yes, this is like a very fair thing to say. Yes?
No. So here's what I think about explainable AI.
Okay.
Let's take your example. We have an image of a cat. Okay, that is chapter 11 of my book. Okay, where you have an image of a cat. In fact, there's an image of my cat in my first book because I like cats. I like animals. So we're sitting together, the two of us, and we're having a nice cake. Okay, and we're having some nice tea. And you're talking about linear regression and all that, and say, Dennis, why did this system produce a cat? And I said, yeah, but this is an image transformer. Yeah, but let's look inside. Okay, let's look inside. It's a Megatron Turing Microsoft model with 5 billion parameters and maybe around 100 layers. Where do you want to begin with your linear regression? We can take 1 million parameters and look at them. How would you say? So I would say the first step there are two visions. I want to understand the input. I want to understand the model. For me, those are two separate domains, which means if I understand the model, then we can go back to your linear regression thing. But what if I want to understand the output? That's only why I was disagreeing. We can look at the model with math. Let's look at the output. I believe in model agnostic explainable AI for the output, not for the model, right? So I didn't invent this. You take the image of a cat and I give it to a cat and it says it's a cat.
You give it to a computer. You give it to a neural network.
I give it to a convolutional neural network.
Not to a cat.
I give it to a transformer. I give it to KMC. I get it to anything you want. But I don't care about it.
Let's move on.
I don't care about the model.
Okay.
I'm model agnostic. I'm not agnostic in real life, but I'm model agnostic in this case. So I take the cat and it says it's a cat. And I say, why is it a cat? Give me an explanation. So now you do anchors. I can group the first image into super pixels, where I just divide the image by groups, like the body of the cat. Let's say it's a black cat, like me. So I just make this big square here. Then I have this building behind me. That's another super pixel. And then I have this stupid face of mine in the middle with this guy with glasses, this ugly guy with glasses in the middle. And I say, how did this system recognize that ugly person? So first I group the super pixels. Then I say, why don't I take the building out? So I take the building out and run it again. It finds that ugly, stupid person with glasses. So it's not the building. Then let's try again. And I take this big, black, ugly jacket he's wearing with his ugly pullover. Let's take that ugly thing out of there. It still finds that ugly, stupid person. So now let's take the face out and send it back again. That's the anchor. The anchor of that image is that stupid face. But what about that face? What in that face makes it different from another ugly face? Why is he so ugly? Oh, the nose. So then you go down, you bring, it's this big nose, okay? So it's anchors. I didn't invent this. It's in chapter 11 of the book, I think. So that's his model agnostic. Now I know why the input did that. And if it's a dog and it comes out as a cat, what made it find it a cat? Maybe it's because it's a little dog that doesn't even look like a dog. There's so many dogs now that look like toys. So it looked like this little toy dog, and then it looked like a cat, in fact, because it was so small that you can find what? So I believe in model agnostic. I just did some Shapley, by the way, as well, because it was anchors. But since I was taking elements out and putting it, so you can say Shapley anchors. So I'm model agnostic. You can bring me any model. I don't care.
So it's not about what we say or what Goodfellow say in deep learning, that you have like in convolutional neural networks, the first layer is just for the shape or just for the simple shapes, and the other layer, the layer underneath, it's going to be for more complex. It's not that route that you are taking, because you are not going to take into this nitty-gritty of the convolutional neural network in the second or third or fourth layer. You don't care about the model. It could be YOLO, it could be whatever you want, yes?
Yeah, so you take Goodfellow. Now, Goodfellow is a book published in a certain year, right? So, and we know how fast things go. This makes no sense, because there's even a video I did on YouTube where I produced an output for every single layer to identify a flower. Then I showed it to my friends and my family. And after one layer, I said, you recognize that iris there? Because that's what they say in deep learning. And they say, I do nothing in there, because it's math. There is no meaning in there. Now that is the old convolutional networks, okay? Now you have transformers using computer vision. There's absolutely no layer like you're talking about. It's just, these layers are identical size, identical function, and they just build up context as they go higher. So
by the way, it's not just that.
The output, but you're not explaining the output by going into the CNN.
I think that like 2 years ago, there was a paper that published that if you take a cat and you put, and you like cover the body of the cat with like the texture of an elephant, it will recognize an elephant. So what we thought about convolutional neural networks was profoundly wrong. So I couldn't agree more. But you need explainable AI in order to trust AI systems. Because if AI system says, okay, you should do this, you should do that, and there is no way that you could back it up with words, no way that you could help the decision maker to understand why the system told you what to do, he wouldn't go for what the system told him. So we need explainable AI in order to have a trusted AI. Is this correct?
Yes. Now, let me tell you something. Remember, I began with Aerospatial, LVMH, and other corporations. Not a single corporation accepted to be delivered with a system you could not explain. They did not care about the algorithm. They wanted on one piece of paper, on one little screen, why that happened. So if I'm in a supply chain and I'm not delivering this ship with the cargo, why? Because of this, and that. So I'm still in my model agnostic mind, because in fact, no one can understand exactly how an algorithm works unless you're an expert in algorithms. So, but we can go to that topic for our domain to explain algorithms. So every time I delivered, I had to explain. Every time I had to give a reason for that, which is why I never even know what the AI winter was about. All I noticed is at the end of the 1980s, there was no one around me. And I only had 5 or 6 competitors in Europe. And even when I went to the States, I only had 2 or 3 because no one was speaking about it. Since no one was speaking about it, I just called it something else. I gave it a name. I called it APS or TPS. I gave names to it. And I lived a very happy AI winter, because what I did is I buried AI deep into the application. The user had nice input interfaces, and outside he always had a reason. I developed other algorithms to say this is why it happened, just like we're in my book. Remember, chapter 1 and chapter 12 are nearly rule-based chapters in that book. Especially chapter 12 is what I was doing. I was writing a lot of rules to find out what it was doing. And the user say, oh yeah, I understand. Yeah, we didn't go to that warehouse because we didn't have enough trucks. Okay. Okay, yes, that's because of this. So I gave him the reason every time. And as long as the user understood, he would confirm the result. I only began to use the word AI again when Google began to speak about it, or around 2006, again, when we had these big servers. So I never experienced an AI winter, exactly for the reason you're saying, is that without explainable AI, you can't deliver.
Because I have a friend, I must tell you.
Trust you. No one will trust you. Yeah.
I have a friend.
Yeah, let me finish. You're in Israel. Okay. You're a third of the NASDAQ is Israeli, right? We both know this. The corporations of the NASDAQ.
Yes.
You have some of the most sophisticated defense systems in the world, because in the old days, I worked on some of the components. So we're talking about extreme sophistication. We're talking about jet fighters with 3D vision under the airplane in the 1980s, okay? Looking at the terrain and everything. So I know how that works. You can go to any company in Israel working on defense. Everything is explained. Because you can't go into complex things without explanation.
This is exactly what I wanted to say. I have a friend who implements machine learning system for the Israeli army, and he says, when I go to the decision makers, the lieutenant colonel, and I say, okay, the system said do that or bomb this building, if I don't have a very solid explanation, they won't count on the system. They want a solid explanations. But from this, which I think is very clear, what you just said. Recently, I had a talk with Gary Marcus, and Gary Marcus basically, his main premise is you cannot trust those AI systems because the mistake that they are doing imply that there is no inherent understanding whatsoever inside. And he even wrote a book just about this, rebooting AI, including many, many, many examples. So one example, with your permission, let me just show you one example, is this one, okay? So it's a very nice example. And this, you show an image of Granny Smith, Granny Smith to a convolutional neural network, like ImageNet, I think. And it will detect that this is an apple, like a special kind of apple with 85% accuracy, which is great. And then on this very same image, you put a Post-it note or a Post-it sticker with a writing iPod on it. And then it has 99.68%. Now the system sure that this is an iPod and not a Granny Smith. And basically what Gary Marcus says, if this is actually the result, the system didn't understand what an apple is. Would you agree with Gary?
That's, I hate to disagree with people because I respect, I would say in the context he was writing, it's true. But in reality, it's completely not true. Let's say theoretically, that's an extremely good example. Fantastic. Okay, I would say excellent book. Fantastic. In my real life, in industry, let me be kind to this person because I respect everyone. It's not true, and I can tell you why. Because this happens every day in industry where I get wrong data. I can give you a very, very simple example. I was working for a chemical company. I'll take your example for a chemical company, and I was recognizing schedules for a certain type of chemical product, but there was noise in the data and stupidity came out of it. It's your example. But if I'm working, let's say, why do I want to look for apples? I'm working in a corporation that's making apple pies automatically, right?
Okay.
How many workers are stupid enough to think that that apple is an iPod? So the first thing you do when you're writing artificial intelligence algorithms for decades, like I have, is you build a rule base for the input, and you build a rule base for the output, and you build like old-time expert system rules input, expert system rules output. Let the system say what it wants, but once I reach there, it's going to follow the categories that I'm doing in real life in this corporation. So if this corporation is working with fruits, and you have this funny guy putting stickers on the conveyor, because I worked for a food company. So you have this guy putting stickers, Gary's there putting stickers. Well, I'm sorry, but my system will detect that there's something wrong because there are no iPods in this factory. And this is completely ridiculous. There will be a little printout that prints out the exception, and they'll build a little thing that calls a manager who will fire the person that did that. So, of course, I can go to your car. Let's say you buy a Ferrari. And I'm saying, a Ferrari is so stupid that I can put vinegar in the gas tank and I will start and the whole engine will break down. Ha, that's how smart I am. And why don't I put some sugar in those Porsches, those nice cars I see? My neighbor has this nice cars. You know what I did? I put sugar in his gas tank and his car broke down. That shows you how stupid car makers are.
Okay, I got, but let me, with your permission, bring 2 points. One, you are absolutely correct that what we are trying to do is like hacking the system. And no normal person would ever stick iPod stickers to and Apple. This, you are absolutely correct. But, and I think this is important, if you want to understand or to be able how far we are from artificial intelligence or artificial general intelligence, I think that these examples shows or demonstrate something. Now let's move on to GPT-3 because we are talking about natural language processing.
Of course. I've been working on GPT-3 for months. So
okay, so we have GPT-3 and from, I think, this week it became free and almost everyone can download it.
No, open access. It's not free.
Yeah, open access, and it's going to cost like 18 cents for 1,000 token. It's barely, it is almost free, and this is a very, and this is a huge platform to interpret language. So you can ask it whatever you want, and you will get great answers. Now,
you're taking a fantastic example, but you're digging a hole. You're going to fall into a hole.
Okay, so let me dig the hole by myself. Okay, so one thing, and I want to do justice with Gary. One thing that I think the main point in Gary's thesis is that you need a holistic approach to AI. Deep learning is not enough. You need learning rule-based system and expert system and other systems as well to build something that like deep learning is not AI. Deep learning is a fundamental part of AI, but it's not just the face of AI. You need, in order to build a robust system, you need many different approaches. Like you said, I need the deep learning, and I need the expert system, and I need the rule-based, and I need the decision tree, and I need the graph. I need many things. And this is one. So I think that Gary goes with you on this. But regarding GPT-3, he says, you cannot, if you test GPT-3 for true understanding, and true understanding is not how to hack the system. True understanding is survey through 100 medical papers and find me the best medical treatment. GPT-3 is very far away from understanding text in the way people understand text. Would you agree?
The problem with your question is, do you agree? So,
no, I'm not.
My dear friend, you have dug a hole the size of a volcano.
Please, the stage is yours.
So let's forget about Gary. Let's forget about what you think. And, let's go back to my good old reality. So let me give you a little metaphor, because I use GPT-3 every day. So, and it goes back to your Apple example too. So let me try to put this together. Let's say I'm going to a corporation, and I have a house to pay. I have my car to pay. And all this theory is very nice, but I have to find a way to deliver this customer. We're not in the books anymore. Gary's not there. You're not there. But somehow there's a problem that cannot be solved with classical software because there are just too many rules I would have to find. That's why I got into stochastic systems in 1991. Okay. I was using Boltzmann equations in 1981 to solve problems because I just couldn't do it with expert systems. There are just too many parameters. So that's another topic, which goes back to what we were talking about, optimal transport and Boltzmann, which goes back to Villani, which I read a lot and I use a lot. So now I'm getting into this company, okay? And just bear with me a few minutes so I can give you the parameters. My first problem is to get paid, okay? I don't care about all this theory. I want to get paid because I need.
You want to deliver.
Deliver and get paid. I don't only want to deliver, I want to deliver and get paid. Otherwise, I can't pay for my family, my house. So that brings me to a constrained world, okay? I'm in a constrained world. Now I'm thinking I have a car to deliver on a road, conceptually. Now, who is the kind of person that has a taxi and says, I want a universal AGI taxi. So you know what? I'm going to drive in Israel. You know what? I'm going to go off the road and take a short shortcut in the desert with a little city car and all the tires blew up. That is a stupid car. That's not an AGI car. I want a car that can go anywhere because it has to be super intelligent. But the problem is I'm entering this company, and if I do that, I won't get paid. So what I have to find is how to drive the car. I'm not looking, I work every day on GPT-3. I spend like 2 or 3 hours using it with all sorts of interfaces. What I'm trying to do is find the road. The problem with people is they think they just have a car, which is GPT-3, but there are no roads. So they're just driving anywhere in the desert. And why don't I fly an airplane with my car? Sure, go ahead. You'll never earn a penny, my friend. If you do that, you're going to go to the company and you'll earn nothing. So what I do is I find the roads of every algorithm, which I've been doing for 40 years.
This is very important. This is very important. The GPT-3 is a car, but
yes,
you need to find the best or the optimal or even plausible road that this car can drive in. Yes, and this is very important. But with your permission, could you elaborate on? Could you elaborate, please, on the road? What do you mean exactly? Let's go back from the metaphor to the real world. What is the road in the context of GPT-3?
Let me give you a real example. There is one task in GPT-3. So I call this prompt engineering, which I didn't invent the word, is GPT writes it. You have to show it, you have to explain, or you'll get nonsense. So if you go to the question and answer thing, task in GPT, it's written. If you put nonsense, you'll get nonsense. So the thing is, people enter, but they don't know how to drive. They don't know anything about language. They don't know anything about artificial intelligence. They don't know anything. Maybe they know how to trick the system. Okay, trick the system, but you won't earn any money. You'll go to GPT-3. Oh, it's bad. Okay. But then the next person like me didn't go through an AI winter because I always looked for the road. I didn't look for what didn't work. So take the question and answer. You take an example. For example, you take an example. John is riding a bike and his dog is following him. It had a flat tire. It had a flat tire. What had a flat tire? You're asking the question. You said, John is riding his bike on the road and his dog is following him, but it had a flat tire. What had a flat tire? And the person that doesn't know how to drive clicks on and it says the dog had a flat tire. And the guy's so happy, he goes straight to LinkedIn and he goes to social media. Look how stupid GPT-3 is and how smart I am because the 175 billion parameters and not AGI and everything. But no. During the AI winter, for other algorithms, I was the little guy saying, maybe there is a way for him to understand. So maybe I should craft my input if I'm delivering something to a corporation to make shorter sentences. So I would have this little parser and I would have a pipeline because every software works with a pipeline. Even accounting software works a pipeline. So it's a prerequisite to say, yes, I have other systems. It's a component. Who would drive a car with only an engine? So I'm going to deliver an engine to you. Tomorrow morning, here's your car. Where is it? Where are the wheels? Oh, no wheels. It's an engine. It's a GPT-3. No, you need a car, my friend. So I'm saying, I'm going to break the sentences down. John is riding a bike. The dog is following John. It had a flat tire. What had a flat tire? John had the bike had a flat tire. And then when it makes, so you have to prepare the input. Okay, if you go to an accounting software, the accounting software is all just put dollars and euros and mix it all up. Yeah, well, look at your accounting. There are rules. You can't use software or ERPs with rules. If you have a sales screen, you can't put your purchases in. There are rules. So if the person doesn't have a driving license, well, then don't use GPT-3. Go and talk to your friends in a cafe. Don't use it. But if you want to use it, it's going to take you hours to find the roads. And once you have the roads, then you will build your input by structuring the sentences, and you will convert the input like you convert all data into any system in the world. So it works, and you'll get a nice output. And then you have a rule base at the end of your output to check if there's not this funny guy putting labels on apples. So in an unconstrained world, people can imagine anything they want. I don't even believe in HEI, by the way. I don't even think it exists, and I don't think it will ever exist. So it's not something I'm worried about, because I built algorithms for 40 years. I can build a transformer from scratch, and it's just a pocket calculator. It's a gigantic pocket calculator. How can it have a consciousness? How can you have intelligence without consciousness? So, okay, and who wants to have consciousness with a computer chip? Okay, so it's even ridiculous to wait. I wrote something called Frankenstein on LinkedIn, and it says, okay, I woke up this morning and I'm a computer, and it's pretty cold in here because I'm in a data center, but I have this, it's Frankenstein. So people think of AGI, it's stupid. I mean, that makes no sense. A tool, yes. So you go to GPT-3 and you read Superglue, for example. You know Superglue? You take Superglue and you print out 100 pages and you read everything. Then you read books on NLP. Then you go with your driving license and you find roads. Once you find the roads that work, you sell it to a corporation and you go home with 100,000 euros, or you can make fun of GPT-3 and then you can go home with nothing.
So I think that your distinction between constrained and unconstrained world, between the theory or the optimal, or like in you know, in the end of time, what will be AGI, or all the philosophical questions which are far from the constrained corporate business world. I think that this is a very important distinction, and thank you so much for making it for the audience and even for me. So this is one. Thank you so much. So with your permission, let me ask you two final questions. One, in your opinion, what does GPT-3 is capable of? And this is question number one. And question number two, how one find or train himself to find the roads for this, for GPT-3 and for other AI algorithms as well? Because I think that your example or your metaphor of we have a car and we need to find the road or build a road, it's a great metaphor. So again, what GPT-3 is capable of, and how do I train myself or better myself in find and build the roads?
There are two ways. Okay, I'll give you the theoretical way is just what I just said. You read, you learn NLP. The second thing is, I'll just tell you how I use it. How I use it every day, and I've gained, I would say, 50% productivity on everything I do. Things that took me 3 hours now take me maybe, I don't know, sometimes 5 minutes. I'll give you one example. There's a task that anyone can go and test, which is the summarizing feature in GPT-3. There's a task, there's a playground. So you go to the playground, and I go to it, and it says, it begins with, I asked my second grade student asked me to summarize the following text, second grade. So we're talking about someone 7 years old, and then there's a paragraph, and then it's written, explain this for a second grader. Now, there are many articles I read that I don't understand, and I want to understand it quickly. So there are things I say, how would I explain this to someone? So I copy and paste a paragraph, and I say, how could I explain that to somebody? And it gives me the summary like a second grader, if this text is structured. And they say, wow, that's a good idea. That is a good idea. Then I said, like yesterday or the day before, I go to the question answering thing, and I say, I'm wondering how you learn. Do you use this corpus? Okay, I was taking a corpus from, did you use this corpus to train the GPT-3? And said, yes. And I say, yeah, but can you recommend a paper I could read on this topic? And it gives me the link to the paper. I click on the link of the paper and I read the paper. but then there are things I don't understand. So now I know that I ask him questions. What is the definition of that word? It gives me the definition. Then they'll give me the definition and it gives me stupidity. So I say, okay, I'm not going to listen to that one. Then I go to the next one. It gave me that answer. So I just take what it gives me and it saves an incredible amount of time. So that I just use summarizing, question answering. Then I go to Codex, which generates code automatically with language. And of course, it only works half of the time. But sometimes it gives me 20 lines of code because I'm using it in different interfaces.
Codex? How do you spell it?
Codex. And I use it with PyCharm. It's an IDE for Python. You download it, and then you integrate the API of Codex, and you say...
We're not talking about Codex by OpenAI, the same OpenAI that has
the
GPT-3.
Codex, right there. Join the waitlist. There you go. Join the waitlist. So you can
there is a big waitlist, I think.
Yeah. So half of the time, it doesn't do what I like. But on the other side, I say, send a tweet. And I just type send tweet, and it gives me the text, the image, and bam, it gives me like 25 lines of code. And I say, hey, I saved a lot of time. So what I'm saying is, after all these years, I know how to find roads. I'm a guide in a jungle. You go to South America and you see, what's that jungle? And then you find this guy like me, this small, ugly guy somewhere. He says, I can guide you through the jungle. He says, how's that even possible? Well, I've been living here for 30 years. I've been doing this all my life. So I always find the road, and it gives me productivity. And the best way to learn is that through the playground. You have to use the playground and find the examples that work.
So you think that the best way to learn and to go into the world of GPT-3 is to download it and play?
Don't download it.
Oh, no. Just, be part of this. It's not download. Yes, it's like...
Go to the playground, but also read everything you can on natural language processing. Because what I do is I've downloaded all of the corpuses on my computer. I spend my days on this. And I take the examples that I know that it trained on, and I put it in the system. Then I change them. And I say, how far can I go away from what it knows until it doesn't know? And now I just create my maps, my roads. I know where to go. I don't know. I save a lot of time. It can give you SQL commands. But you have to find the road. It's like life. When you're 15, life is chaos. You have to find your road. Okay, so these systems are so big, they're chaos. You have to find your road.
I think that your distinction about, the constrained versus unconstrained, the theory optimal approach versus the business corporate approach is eye-opening. Et c'était au grand honneur parler avec toi ce soir.
Oh, tu parles
avec plaisir. C'était un grand plaisir pour moi. Et vous êtes très sage, peut-être trop sage. No, it was, again, it was fantastic. I learned so much. And, after reading Gary's book, I was feeling a little bit disappointed about, how far we are from AI. And again, Gary has a great book, but what you just gave me a different, fresh perspective. Again, this is what Gary says is absolutely correct in this context. But if you look at different context, it doesn't matter. And no. I think that your distinction was great. So thank you so much, Dennis Rothman, for joining me today. And thank you so much for your books. If one of my viewers is new to your books, would you recommend start with AI, artificial intelligence by example, or Transformers for NLP?
What the reader wants. But then the reader can always contact me on LinkedIn. I answer every single question. Anybody in the world that asks me a question, I always answer the question.
Dennis, Rothman, you are such a nice guy. And the next time I will be in Paris, I will certainly be in touch. Thank you so much for your time. It was wonderful speaking with you today.
It was wonderful speaking to you.
Okay, bye-bye.